More than 250 experts in the traffic signals industry joined together in person to hear a range of papers here in Nottingham. These recordings are brought to you by AGD Systems, Colas, SRL Traffic Systems, Smart Video and Sensing, Vivacity and Unex Traffic.
Yeah, first time I've spoken in front of a real-life crowd in 2 years, so it's a little bit daunting. My name's Andrew Caleya Chetty. I head up Starling Technolgies. We are a new UK-based company. We born out of a large project we did back in 2017 at Umbrellium with Direct Line, and since then created Starling and have a long and collaborative relationship with Colas, which I'm going to touch on, but also talk about some of the stuff that we do independently of Colas. We have 3 products: Starling Control, Starling Intelligence, which are 2 of the ones that we work with Colas in France, and Starling Detector, which is a curbside detection plus data that we are starting to look we're starting to trial in the UK. We have a computer vision-based detection system for use with traffic signal systems that can deliver a lot more than simple presence or absence detection. We can compile the number of pedestrians, total accumulated waiting time, and even predict intention to the use of crossings from trajectories on pavements. We have a complementary back office service that can extract metrics on traffic behavior, identify different types of behavior of both pedestrians and vehicles at crossings, and for that matter of fact, anywhere on the network. Our trial work so far in conjunction with Colas has been part of the FLOWELL product development, and Pierre will talk a little bit further about that. I would have loved to show you a lot more information around the work that we're doing in France, but because of COVID and because of the restarting in France, we're not as far on as possible, but these 2 are just about to go live in France itself. We also have another trial, again in collaboration with Colas, with a UK site in Portsmouth that is going live this week, and are in dialogue with a number of other local authorities about trials. If anyone is interested in having this conversation about trials, please come and see me. I am more than happy to have that. I would note that we've had lots of fruitful conversations with local authorities about high quality and more diverse information about pedestrians and cyclists at crossings and junctions that could not only inform timings and control strategies for crossings, but influence design and placement. So I'm going to now touch on Starling Intelligence, one of the products, which was born out of conversations that we had with local authorities and their specific data needs at junctions and across their network. Starling Intelligence exposes our detection, classification, and behavior analysis and makes that available. The types of users would be local authority traffic engineers, like a lot of yourselves in the room, public transport operators, again, similar people in the room, and different types of city planners, so they can get the benefit from the data derived out of Starling. The next couple of slides I'm about to show you is some offline metrics that we can provide that are associated with a crossing. We've explored standard metrics that could be used to describe this type of activity, and it's not something that we found. So I am really keen to collaborate with as many people as possible to be able to come up with these standard metrics that can be used by all cities to describe the efficiency and validation of networks such as active travel networks. Sorry, apologies. So these two slides here show the type of behavioral data that Starling derives from surveys. This data might be used to determine pedestrian timings for signalized crossings, or for different user types at different times of day, so that the data shows that an older demographic during a daytime may need longer clearance periods than a more agile demographic, agile and older demographic that could just have standard clearance times. So I'm just going to flick onto this. So what we did here, so the way that Starling Intelligence works, it is we can either put our own equipment, and this is what's in Portsmouth at the moment, at crossings or junctions, or we can use supplied video footage. For this test, which we used a public cam network called EarthCam, and we used the crossing made famous by the Beatles at Abbey Road. And the data that you're seeing on the side of this spreadsheet is some of the data that we got, aggregated data over the time periods. Data can be presented by direction of travel, specific intervals during the day. We can also monitor how people respect crossing delineations, how many leave or enter dropped curbs. We can create desire lines that are not compatible with crossing placements. So just to sum up briefly before I hand over to Pierre, we have a detection product that includes computer vision and AI to monitor and report on pedestrians, cyclists and vehicles. We can provide real-time real-time data for traffic control purposes, and we'll be taking the product through the EMC environmental and Topaz processes very soon, as you would expect. We can also use this. We can also use the data from these detectors to generate metrics for pedestrians, cyclists, and vehicle behavior and interactions. The equipment used for the control applications, of the monitoring and surveys, and any of you progressing active travel may find the latter applications useful for your before and after studies. And this is exactly what we're about to start in Portsmouth. Thank you for your time. I'm going to hand over to Portsmouth. I'm going to hand over to Pierre. Please come and find me if you would like to continue this conversation.
Thank you, Andrew. Good afternoon, everyone. Smart new ways of detecting traffic activity. But there's a bit. And on my side, I'm going to tell you a few words about a new option for delivering information to road users. This is called FLOWELL. This is an innovation developed by the Colas group. So basically, what are we talking about? It's FLOWELL is just a combination in between traffic signal, road marking, road studs. Basically, that's a very slim panel. In fact, it's a multi-layer compound of composite materials encapsulating an array of LEDs. And this array of LEDs can be operated throughout a control system on and off to create a fully dynamic road marking. So in a few words, the visibility we can deliver with that system is extremely high and visible at all time, from during nighttime, of course, which is easy, but also under snow or under sunny weather. We can deliver some specific shapes and colors depending on the use cases. and the product is usually just simply sit on top of the asphalt. As you can see on the picture, we can be using two versions of the product, or a fully black one that allows to create a fully dynamic road marking that is visible only when the LEDs are activated. And alternatively, and especially for compulsory road marking, we are using a white version that stays visible at all time, even when the LEDs are not activated. Is the movie self-running? So far, so I'm going to pass on that one. So far, we are, let's say, in a trial phase. We started a couple of years ago, and we have done something like 15 projects in France, one in the US, and soon in England. Mostly urban use cases. A lot of crosswalk and more recently some bike priority management projects. All the projects we're doing now are under the scope of authorities, because FLOWELL is quite disruptive. It's nowhere in the regulations because it's not a road marking, it's not a traffic signal, it's a brand new device. And all the projects we are doing are monitored by impact surveys to measure the benefits of that device. You know, a couple of years ago when we went and see the French Ministry of Transport, said, okay, we have a new stuff. It's gonna make things better and improve road safety. And the answer was, yeah, prove it. And that's what we're doing. So all those surveys are conducted by independent and specialized survey companies appointed by the French Ministry of Transport. And this is, I'm going to show just a few data of a few KPIs. For example, on that one project in Mandelieu, the very first one, almost 3 years ago, the braking too close to the pedestrian and the number of priority denial was reduced by something like 30%. Traffic obstruction at the intersection on the film we've just seen. Yeah, we're looking at more than 50% reduction of obstruction, meaning that bus drivers don't need to go around cars, stop at the junction anymore. And more recently, that one is a crosswalk in Paris. Though we could measure that, well, some serious reduction of bad behaviors, like vehicles stopping past the giveaway line or pedestrian priority denials. The initial numbers are stunning, but truly that's what we measured. 30% of the drivers were denying priority to pedestrian. not that fair, but the truth, and that's what we measured. And so we can see that the impact of a highly visible and fully dynamic road marking, well, makes a difference. So I think I'm overrunning my time. If I have some question, if you have anyone has some question, I'd be happy to answer. Thank you.
Well, thank you very much, gents. That was certainly not quite what I was expecting. I should have read the papers beforehand, but there you go. Certainly very interesting. So I can see that Lyndon from Reading is keen to ask a question. Maybe it'll be asking about the resilience and skid resistance of the product, but we'll see.
Actually, I'm going to leave that for somebody else. Mine's more quite simple. How's it powered? Does it need to link up to the next module? It's more about how easy it really is to install.
This is how it works. I passed on quite quickly on that one because I saw that time was running. So the panels are all connected to our proprietary control cabinet. So that cabinet ensures different functions. The first one being the brightness control. The brightness is adjusted in real time to prevent glare effects or so on. So that cabinet also does the power management, well, there's a computer inside where we can define operating scenarios for the use case we have to deal with. And that computer basically can be connected to any traffic system. It's fully open. It's not depending on any protocol, communication protocol or whatever. It can be simply it could be a push button, it can be a traffic controller and in that case, our control cabinet will become a slave from the traffic controller. It can be a simple traffic camera, traffic radars, any kind of sensor.
It could also be Starling, which it
is.
It could
be, yeah, that's what I meant about a specific traffic camera, but our system is fully open, completely open.
Yeah, I think you kind of missed the point. It's how is it physically connected from the panel back to your controller, the cables in the ground.
Yes, slot cutting.
Obviously we get trenching and all, even just plain slip of the asphalt itself. What is the cable? Is it resilient against stretch, for example? How visible is it to a civils team that's coming along digging up?
It's almost invisible. We are talking about quite thin slot cutting of 2 centimeters, 7, 8 centimeters deep, and of course each module is connected to the electrical cabinet by cables. But it's hardly visible.
Yeah, which makes it more difficult for a civils team to spot that aren't necessarily going to know it's there.
Yeah.
Yeah. Okay. Cheers.
Okay. Any more questions from the floor? I can see that particularly FLOWELL is going to have possible applications in tunnels, or you've got very high volumes of pedestrians in, not even in the traffic situation, but say at a stadium or at a station or an airport. I can see that that's going to be useful. I was thinking even perhaps on shuttle working signals, where if you've got a particular problem, the fact that you've got lights to follow, it's going to cut out some people's excuses. And I was also going to wonder, as the two of you are presenting together, is there any interplay between the two technologies that you've investigated?
I mean, that's why we're presenting together. So FLOWELL, the examples that I gave of the collaboration with Colas and FLOWELL are ones that are going in to France, and Starling becomes the detection and decision-making system. But it's primarily there for more advanced or complex junctions. which usually has pedestrians, cyclists and vehicles and others that need a kind of closer management.
Thanks very much, gents. So,
Thank you.
yeah, that was really very interesting. So, thank you both.
Thank you.
So, if we could just thank our contributors for the session this morning.